Alright, ladies and gentlemen, today we are moving on to Topic 9, Lesson 2. So the first method that we learned in how to solve quadratic equations is graphing. Today we're going to talk about how we can use factoring to help us solve quadratic equations. Now, we focused on factoring during Topic 7. That was all that Topic 7 was about when we talked about finding the GCF and when we talked about the AC method and factoring by grouping and things like that. So we're going to bring that back in and we're going to factor quadratic equations that will then help us find the zeros to those equations without having to look at the graph. So on the left hand side of today's notes, we're going to talk about this very, very important property called the zero product property. What this says is that for all real numbers, remember real numbers are fractions, decimals, positives, negatives, all of that. For all real numbers, a and b, if a times b equals 0, then a must equal 0 or b must equal 0. Okay, so I have a few examples down here I'm going to talk about. So if we want the product a times b to be equal to 0, we have to have one of those two numbers be equal to 0. So if I have x times y equals 0, what that means is that I could say, well, x is equal to 0, and that means that y can be anything. Could be 0, could be -1, could be 1/2, could be 500 million. But as long as x equals 0, then that whole thing will hold true. Same thing goes for y. If y equals 0, then x could be anything. If y is equal to 0, then 0 times no matter what x is, that product would still be 0. Okay, now if we move down here, we have this x times this quantity y plus 2. Now, it's simple. If x equals 0, then y can be anything because 0 times something equals 0. Now, how do we get this equal to 0? Y must be equal to -2. If y equals -2, then this here is equal to 0. And then if this is equal to 0, then x can be anything. Okay? Same thing goes for this last one. If I want this here to be equal to 0, then x must be equal to -3. And I'll show you this work over here. If I want x plus 3 to equal 0, I must subtract 3 from both sides to get x equal to -3. Okay? If that's the case, then y can be anything. If I want y plus 6 to equal 0, then y has to be -6. And if y is -6, then x can be anything. Now, if you notice this here, this is what factored form of a quadratic equation looks like. So you're going to be given quadratic equations that then you have to factor down to something like this, that then you're going to use the zero product property to find the solutions. So let's do an example. X squared plus 9x equals -20. Now, one note that I need to make before we move on is that if we want to solve by factoring, quadratic equation must be in standard form and equal to 0. So I cannot have a number over here on the equal sign. I need to move that so that it's in standard form and set equal to 0. So I'm going to add 20 to both sides. And I get x squared plus 9x plus 20 equals 0. Now, remember with factoring, we're looking to figure out what multiplies to get 20 and adds to get 9. If I think about factors of 20, I think 2 times 10, 4 times 5, 4 times 5, 4 plus 5 is 9. So those are the factors that I want. And I'm going to rewrite this as x plus 4 times x plus 5. Now, this is where the zero product property comes in. This either has to be equal to 0 or x plus 5 has to be equal to 0. Now, they both could be, but they both have to be. So I'm going to set them both equal to, subtract 4 on both sides here to get x equals negative 4, subtract 5 on both sides here to get x equals negative 5. Now, this particular quadratic equation would be one like this, where if I graphed this quadratic equation, there would be two zeros, one at negative 4 and one at negative 5. And I'm just going to write that off to the side. You don't have to do that. I just want to make sure that we're recognizing the connection between this and the graph. So there'd be two x-intercepts here because it crosses the x-axis in two different places. Now, example 2 might get a little bit more complicated, where we might have to factor something that we can't recognize right away. And it also has this a term where we have to use the AC method. So remember with the AC method we multiplied there first. So 5 times 18 is 90. So we're looking for what multiplies to get 90 and adds to get negative 43. I'm thinking, 45 times 2. One of them has to be, negative 90. The negative 45 would give us negative 43. So I'm going to use factoring by grouping, and I'm going to plug that in. 5x squared minus 45x plus 2x minus 18 equals 0. Then remember, this is where I group these two together and have to pull out the GCF, so I'm going to pull out a 5x here, and I'm left with x minus 9, and then I'm going to pull out a 2 here, and I'm left with x minus 9. So when I rewrite this, I'm left with 5x plus 2 times x minus 9 equals 0. That's all review from topic 7. So all of that factoring we just did, the new part comes right here where we say, okay, zero product property tells us that this has to be equal to 0 or this has to be equal to 0. So 5x plus 2 equals 0 or x minus 9 equals 0. Minus 2 on both sides. Divide by 5 on both sides. So x equals negative 2/5. Add 9 on both sides, or x equals 9. Again, two possible solutions. Okay? Now, you might get something that has no solution. You might get something that has one solution. Now, if you got something that was no solution, That would be a quadratic function that's not factorable. If there is no way that you can factor this at all, that's a no solution. If it only has one solution, it would be something like a perfect square trinomial, where you get something like x minus 2 times x minus 2 equals 0, or x minus 2 squared, that's the same thing, equals 0. That would be that the only solution is x equals 2. Okay, so these are those little specials. You very often won't see a no solution. Tonight on the homework there isn't any no solutions, so you should be able to factor all of them, but you might see one that is a one solution one, where there's only one answer instead of two. Now what I would like you to do is I would like you to pause the video here, go on to enVision and check out example 3, and then come back here and we'll go through it together. So I drew a picture of example 3 because that always helps me. The steel safe or vault was 20 by 40, and it had this X surrounding it. That's what we're trying to determine what that distance is. What is this X distance? So in order to do that, we have to create a quadratic equation. Okay, I know that this entire length of the vault is x plus 20, so 2x plus 20. And I know that the entire width of this vault is x plus 40, so 2x plus 40. And they told me that the entire area of the vault is 1,664 feet squared. So I'm going to multiply those together to get that length. Now remember, when we're solving to find the zeros, like what x values work, we have to get this to the other side. I can't do that yet because I don't have like terms. So I need to do the double distributive property, multiply that all out, and get 4x squared plus 80x plus 40x plus 800 equals 1664. Now I'm going to combine like terms, and I'm going to subtract that 1664 to the other side, all in the same step. So 4x squared plus 120x minus 864 equals 0. Now these numbers are huge. I'm trying to find what's going to multiply to get me hang on. These numbers are huge, but there is a common factor that I can actually divide by. 4 goes into all of these things. So I'm going to simplify that to get x squared plus 30x minus 216 equal to 0. Now, 216 is still a large number, but I'm trying to figure out what multiplies to get 216 and adds to get 30. Tests and quizzes won't have numbers this large, but we're going to say -6 times 36. And that gives us positive 30. So I'm going to rewrite this as x minus 6 times x plus 36 equals 0. Now, zero product property says that x minus 6 equals 0 and x plus 36 equals 0. Add 6 to both sides. X can equal 6, or minus 36 from both sides, x can equal -36. Now, because we're dealing with a story problem that is talking about the length of this steel vault, x equals -36 doesn't make sense. I can't have a length of a negative value. So, x has to be equal to 6 feet. That is the solution that works. If I plugged this in to my original equation, 12 plus 20 is 32 times 12 plus 40 is 52. Oops, sorry. So if I multiplied 32 by 52, I get 1,664. So I know that I'm correct.